So welcome to the lecture on the knowledge model of the Common CADS model suite. This picture will remind you where we are in the story. Initially, we discussed very high-level and abstract models called context models, and these were meant to capture information about the context in which the presumed knowledge-based system that we're going to build is going to function. We were capturing information about the organization, about the tasks that are performed in that organization, how the different agents are interacting in those tasks. And after making those context models, we would have decided if we were going to support the organization with a knowledge-based system, and if so, what task we are going to pick to support. So after deciding that, we should decide what knowledge is actually required for supporting such a task. And that is the key role of the knowledge model. So the knowledge model is really the most central element in the Common CADS model set. And you will spend in your project most of your time filling in the details of the knowledge model, because the knowledge model is really a crucial bridge between these very abstract models at the top and the very concrete design model and implementation that we are ultimately after. So this knowledge model is really a key central switch. Just to give you a brief overview of the background of this knowledge model before we dive into the three main components. So traditionally, the structure of a knowledge base, and now I'm talking the early days of knowledge-based systems in the 70s and 80s. So traditionally, the knowledge-based system consisted of two parts. One part was of course, the domain knowledge that the knowledge-based system contained. So, for example, knowledge about diseases, if this was about treating a patient, or knowledge about cars, if this was about either designing a car or repairing a car. And the second part was an inference engine. So the engine that would use the knowledge base to actually perform the reasoning. And of course, a crucial third ingredient was the input data. So if you are diagnosing a patient, you need lots of generic knowledge about diseases, you need a generic diagnostic inference engine, and of course, you need specific information about a particular patient, the input data. And one of the key insights from research on knowledge-based systems is that it is possible to reuse the knowledge base and the inference structure, the inference engine. So let me give you two directions of a reuse. So the first direction is the idea that you can use the same inference engine with different knowledge bases. So whether you're diagnosing a car, or whether you're diagnosing photocopiers, or even to some extent when you're diagnosing people, patients, the structure of the reasoning is always the same. So the idea is that you can use the same inference engine for any diagnostic task and just replace the knowledge base to tell it about the structure of photocopiers or the structure of cars or the structure of patients. And you could reuse the same inference engine with different knowledge bases. We could also play this game the other way around, and we could use the same knowledge base for different tasks. So a good example of this is what happened in Fiat, the Italian automobile producer. So in the early years of this century, they were the first ones to be very advanced with diagnostic systems to support mechanics in the garage. So if there was something broken with your Fiat, you would drive your Fiat to the garage, and the mechanic would plug your Fiat into a computer, and the garage computer would diagnose the car. Now, of course, the system needed lots of knowledge about the construction of Fiat cars. And Fiat realized that this knowledge was already available. It was available from the design phase of these cars. So what VIA did is they took all the knowledge they had about the design of cars and reused it for diagnosing cars. And so here we are using this same knowledge base, namely knowledge base about the structure of Fiats, and we're using it for two different tasks. It was used for designing Fiats and it was used for diagnosing Fiat. So we can play this reuse of knowledge base and inference engine in both directions. Now in later developments of the knowledge base system theory and practice, it turned out that this rather traditional and rather simple structure of two layers, an inference engine and a domain knowledge base, was a little bit too simple. This led to splitting up the inference engine into two layers that were going to be called the task layer and the inference layer. Right? So you see here in large, you see the same picture as you see above in small, except that the inference engine has now been split up into two parts, a task layer and an inference layer. And similarly, the knowledge base has been split up into separate parts, a domain scheme and the actual domain knowledge. So the bottom picture is the modern picture about the structure of knowledge-based systems, and it's a refinement of the classical picture of the structure of knowledge-based systems. So this leads us to three layers, if you want, three types of knowledge: the task knowledge, the inference knowledge, and the domain knowledge. So doing this from the bottom up, the domain knowledge captures knowledge about the particular application domain of knowledge-based systems. So are we diagnosing photocopiers or are we diagnosing cars? The inference knowledge captures the basic reasoning steps that are required to perform a particular task. So what reasoning steps are required to do diagnosis, or what reasoning steps are required to do design. And the task layer captures the control knowledge, sort of how do we impose a control flow over the steps from the inference layer. So this picture summarizes what we said in the previous slide, right? And now from the bottom to the top, we start with the task layer. So the overall goal of the system, decompose this goal into sub-goals, and maybe further decompose this sub-goal into sub-goals until we arrive at subtasks which are simple enough so that we can call them atomic, simple inference steps. So the task layer is concerned with this decomposition, and it is concerned with expressing a control flow over these subtasks. Now these elementary or primitive or atomic subtasks, they will be the elementary inference steps of the inference layer, and the inference layer tells us what each of these steps do and how it takes input, then does an inference step and produces an output, and it tells us how these steps are chained together in order to perform a particular task. And of course these inference steps, they make use of domain knowledge. So they refer to domain knowledge, and the domain layer tells us what is the structure of this domain knowledge that is being used in the inference layer. And what we're going to do in the next three parts of this lecture is we're going to go through each of these layers from the bottom up. So we'll start with the domain layer, then we'll talk about the inference layer, and then we'll talk about the task layer.